Hello, class. It is Max and
Me, Zack, hello.
here with a lesson on points of inflection. So, with this lesson, we have two goals: understanding what points of inflection are and being able to find points of inflection mathematically with your original function, a first derivative, and finally a second derivative, which is going to be the primary part of finding your inflection points. So, we want to give a little recap on concavity. In simplest terms, your concavity is transition from increasing or decreasing slope of a curve to a decreasing or increasing slope, which is dependent on whether or not you're in a situation where it's concave upward, as you can see highlighted by the pink-purple color, where it goes from a decreasing slope until it reaches this critical point, which here is our minimum because it's at the bottom, to increasing. Quite the opposite is with concave downward at this maximum, which is also our critical point, another one of our critical points rather, where it goes from increasing to decreasing. So you could also see this in our first derivative, where it goes from negative to positive at this critical point. So we have our negative here, goes to a critical point, becomes positive. And that would be our concave upward, and then our concave downward goes positive to negative at this critical point. So now that we have our critical points out of the way and understood, we want to talk about our points of inflections, which could be considered the transition from where it is here, in this case, concave upward to concave downward, or vice versa if it was the opposite way. So we see it here, bring it all the way down, because it's also there in your first derivative, and in our second derivative, which is what the equation we're going to be using to find them, it can be seen as a switch in sign, or positive to negative or negative to positive. In this case, we see it is going from positive to negative. So now that we have a little bit of an understanding of concavity, we will go to our first problem. So Zach, you want to help us out?
Yup. And our function is negative x cubed plus 3x squared plus 1. And we are going to breeze by this. Okay, so we find the first derivative, and hopefully you know how to find the first derivative of negative x cubed.
Right, we use our ability to derive.
Yep.
Negative 1 times 3 is negative 3 squared, because you subtract the 1. 3 times 2, 6x. 1, we know there's no x there, so it's got to be 0, guys.
We got our derivative. There we go.
Yep, negative 3x plus 6x. So now we're finding our critical points by saying it equal to 0. And in doing so, we find our two little mini equations, 3x and negative x plus 2, set them equal to 0, do the math we know, get 0 and 2 for our two critical points.
Boom. Now you find the max and the min. We take our critical points, we put them on that number line, then we go to the left, we go to the middle, and we go to the right. Alright, so now it goes negative, positive, positive, because we plugged it in.
And you get a negative 3, positive 9, and a positive 45 for negative 1, 1, and 3 respectively. So, understanding that our maximum point would be where it goes from increasing to decreasing, our minimum point being where it goes from decreasing to increasing. We can see that 0, where it goes decreasing to increasing, is a relative min, and a relative max in this case, while it goes positive positive, for the time being we're going to consider it a relative max. And also we could consider this part, because it is going decreasing to increasing, a situation or an interval where we are going concave upwards. That is right, ladies and gentlemen, concave upwards. So now we want to find our second derivative, and we use our same deriving powers that we all have, and thank Ms. Bethan so much for understanding.
And we get negative 6x plus 6.
That's right. Next, this will be important in the next slide. We're going to find those points of inflection by doing what we did to find our critical points, and that is setting the equation equal to 0. We get our math, we do it, and we get a negative 1. So, excuse me for the double take. Then what we want to do...
we actually get 1.
1, that's what I said. So, sorry. So, next thing we want to do is we want to go from the left and the right. We find out if the sign is changing from positive to negative or vice versa. As we see, it goes positive to negative, positive to negative. So lastly, we want to find where, or what the coordinates of that point of inflection is.
We plug in. If you look in the top right corner, we plug our inflection X point thingy we just got back into the original.
Make sure you do the... Okay, so our second problem is to find the inflection points for the equation f of x equals 4x to the fourth minus x to the third plus 2. So, okay, oops, went the wrong way, and okay, we're there. So our first step, as with the last problem, is to find the first derivative. And to do so, let me click some buttons. You're going to use the deriving powers we know. We multiply 4 times 4, we get 16. Subtract 1 from that power and you get to the third. Then you do the same for x to the third and you get 3x squared. And as we know, the derivative of just a constant is going to be 0. So our second step is to set that equation, or the first derivative equal to 0, to find our critical points. As we go through, we can find those two little mini equations, that being x squared and 16x to the third. And when we set those both equal to 0, apologize, that should be an x squared, we get 0 and 3 over 16. So there we go. Now we're on our third step, which is to find our relative maximum and minimums. So to do so, remember we want to test points both on the left, in between, and right of our 2 points. And in doing so, we get a negative, a 0, which I did not put anything there, but that's supposed to represent a 0, and a positive. But you can kind of think of that 0 as almost like a positive, because from negative 19 to 0 is going upwards. So with that in mind, we can see that 0 is going to be our relative minimum, and although when we graphed it, when we put the equation into a graph, we found that it actually looks like a parabola. For the means of the math, 3 over 16 is going to be your relative max. And just to think about concavity, being that it's going from negative to positive, we could consider this as being concave up, and it is because it opens upwards. So the next step is going to be find our second derivative, which will lead us to finding inflection points. And using deriving knowledge we have, we can see 16 times 3 is 48, make that a x squared, and 3 times 2 is 6, and drop that so it's just 6x. So for our fifth step, we're finding our inflection points. We can make our two little mini equations with 6x and 8x minus 1, because you see 6 8s are 48. We set both these little mini equations equal to 0, and we get 0 and 1/8. Then we want to test those points, or test to the left, middle, and right. And we get a 54, which is positive for something to the left. We get a negative 3 over 16, when we put in 116, which is in the middle, which is a negative, and then we get 180, which is a positive. So we will find our points of inflection. Remember, we have this up here for a reason. You are plugging it into the original. And in doing so, you find when you plug in 0, you get 0, 2, because f of 0 is 2. And when you plug in 1/8, you get 1.99, making your point of inflection, I don't know why this keeps getting cut off, I'm sorry, 1/8, 199. So we hope our little lesson helped you guys figure out or remember some more stuff about points of inflections, and go calculus.